Today we're going to talk about Lesson 4-7, Equivalent Formulas. The big idea is if a formula gives a first variable in terms of a second variable, it may be possible to transform the formula to give the second variable in terms of the first. I want you to remember that equivalent formula means equal formulas. So that means just by doing inverse operations and moving things around, you still have equivalent formulas. It's just that you may want to find something different than what they had solved for in the first place. And we're going to talk about that in just a little bit. But it says two different temperature scales are common used throughout the world. The scale used wherever people use the metric system is the Celsius scale, named after Anders Celsius, a Swedish astronomer and physicist. It is also sometimes called the centigrade scale because of the 100-degree interval between 0 degrees Celsius and 100 degrees Celsius. The freezing and boiling points of water, we should all know that. 0 degrees Celsius is freezing, 100 degrees Celsius is freezing, or is boiling, sorry. The other scale is the Fahrenheit scale. We should all be familiar with this. This is what we use in the United States. The Fahrenheit scale, which is now used only in the United States and a few other countries, water's freezing and boiling points are 32 degrees and 212 degrees, respectively. It says people outside the United States seldom use the Fahrenheit scale. An exception is when a visitor from the U.S. asks what the weather forecast. They have to change the Celsius temperature from their forecast into Fahrenheit using the formula, and this is a formula, F equals 1.8 times Celsius plus 32. This formula uses Celsius temperature as the input and produces the Fahrenheit temperature, F, as the output. So C would be our X, F would be our Y. You put in a number, C, you get out a number, F. We say that it gives F in terms of C, what you're getting out in terms of whatever you are putting in, F in terms of C. However, visitors to the United States have to make the reverse conversion. They must convert Fahrenheit temperatures from the U.S. forecast into Celsius. If you are going to convert from Fahrenheit to Celsius often, it is convenient to have your own formula that begins with F as an input and gives C as an output. To find this formula, we write 1.8 as a fraction 9/5. Okay, so what they did was convert 1.8 to 9/5. Okay. So let's look at example 1. Solve F equals 9/5 C plus 32 for C. Okay, so as I said before, they changed 1.8 to 9/5 just to make it easier. So all we are doing is going to use our inverse operations. And what we are doing is we are solving for C. Okay, that means get C by itself. To do that, inverse operations. Whatever we do to one side, we have to do to the other. So, here's my C. That means C's on the right side. That means I got to get rid of this 32 first. The inverse of adding 32 is subtracting 32. My 32s are gone. Okay. Leaves me with 9/5 C is equal to F minus 32. Yep, still leave the F in there. F minus 32. It's not a negative 32F. It's F minus 32. So then what do we got to do? Well, we still got to get C by itself. If you remember, Mr. Johnson said whenever you see a fraction, the inverse of multiplying by a fraction is dividing by a fraction, which is the same thing as multiplying by its reciprocal. The reciprocal of 9/5 is 5/9. Whatever I do to one side, I have to do to the other. Okay? So my 5s are gone, my 9s are gone. Leaves me with C equals 5/9 times the quantity F minus 32. So, what does that mean to you? Well, if you're a person that lives outside of the United States and you want to know the Celsius temperature while you're in the United States, say for instance, you wanted to, it's 72 degrees in the United States, so when F is 72 degrees, I'm going to put 72 in for F. 72 minus 32 equals C. We all know 72 minus 32 is 40. 40 times 5/9, so 40 times 5 divided by 9 gives me 22.2 degrees Celsius. Okay, so what that's going to tell somebody that's outside of the United States, it's pretty nice out, 72 degrees, okay? The formulas F equals 1.8 C plus 32 and C equals 5/9 times the quantity F minus 32 are called equivalent formulas, because every pair of values of F and C that satisfies one equation also satisfies the other, okay? If I were to put 22.2 in for C here, multiply it by 1.8, add it to 32, as you would see, you would get F, or approximately, because I kind of rounded. So let's try that out. F equals 1.8 times C, which I said was 22.2. And like I said, I rounded, so we might end up being a little bit off from 72. But 1.8 times 22.2 equals 39.96. And as you can see, I'm already off. But plus 32, and you get 71.96. Is that close to 72? Yeah. So it's going to work. The reason why we're off, like I said, is because I rounded to just 1, 2. Okay? Example 2 says, a formula for the volume of a cone is V equals 1/3 pi r squared h. Now, a lot of people like to write this as V equals pi r squared h all over 3. Okay? They don't like that 1/3 out in front. They like to see what it means right here. So I like to write it like that too, especially when you are using equivalent formulas. V is the volume, R is the radius of the base, and H is the height. Octavio solved this formula for H. His work is shown below. Explain what he did to get each equation. So what Octavio is saying is, he's got an H right here on the right-hand side. That means my 1/3, my pi, my r squared all needs to leave. It needs to be gone. So if you look at this, what he did was first get rid of the 1/3. Well, the first thing, the inverse of multiplying by 1/3 is multiplying by the reciprocal. So what he did here was he multiplied by 3. And how we know he multiplied by 3? Well, V turned into 3V. Okay? So his next step here, it looks like he wanted to get rid of the pi. Well, what's pi doing to H? Well, everything side by side means multiply. So what he did was he divided by pi. Okay? Then what did he need to do? Well, he needed to get rid of the r squared. So he also needed to divide by r squared, because the inverse of multiplying by r squared is dividing by r squared. Now, could you divide it by pi r squared up here in the second rung? Yeah. If you would have just did this and said I need to get all this away from h, you could have said divide by pi r squared. And that means you had to do it to this side, pi r squared. That means these are gone, leaves you with h equals 3b divided by pi r squared. So you could have skipped that second one right there. They just kind of wanted to show you how he got to that. Okay? Remember, solving for a variable just means get that variable by itself. It doesn't matter that these variables aren't numbers. Okay? Leave them as variables. It's fine. That's what a lot of times kids struggle with. So number 1 says a negative 6x plus 3y is equal to 24. And they want us to solve for y. That means get y by itself. Well, where's my y at? Well, my y is on the left side. Okay? So everything else needs to be moved to the right side. So the first thing I got to do is get rid of this negative 6x. The inverse of subtracting 6x is adding 6x. Whatever I do to one side, I do to the other. The 6x's are gone. Leaves me with 3y. Equals 24 plus 6x. Can you combine those? No. Girlfriends, non-girlfriends. 24 plus 6x. Okay? Is y by itself? Y is not by itself. It still has a 3 on it. The inverse of multiplying by 3 is dividing by 3. Y equals 24 divided by 3 is 8. 6 divided by 3 is 2. And don't forget your x. This problem right here is going to come in handy because what you have to do is if you're given an equation, you have to solve for y to put on your calculator. Because all we have is we press the y equals button and then you got to type in and say whatever y is. Same thing here. You couldn't just type this equation into your calculator. You have to type in 8 plus 2x to see what happens. Okay? So very important strategy to know. 3. S equals c minus 1 all over 3. They want us to solve for c. This formula comes from the formula for a cap size, S, when c equals the circumference of the head in inches. So in this case, we know the circumference, we're going to find the hat size. When we solve for c, we're going to know our hat size, but we want to know how many, what the circumference is in inches. Okay, is what that's going to tell us. So, moving on. Solve for c. S equals c minus 1 all over 3. C is on the right side. I got to move everything else. So let's get rid of this denominator first. The inverse of dividing by 3 is multiplying by 3. Whatever I do to one side, I do to the other. Gives me 3s is equal to, okay, 3's are gone, c minus 1. Is c by itself? No. So what do I have to do? The inverse of subtracting 1 is adding 1. Whatever I do to one side, I do to the other. 1's are gone, leaves me with c equals 3s plus 1. So, what is that saying? Well, say for instance, Mr. Johnson had a hat size of 7. Okay? So S equals 7. Hat size Okay? So I put 7 in for S. 21, 7 times 3 is 21, plus 1 is 22. So C equals 22. So when S is 7, C equals 22, and that means 22 inches is the circumference of my head. Pretty neat stuff. That's why we have formulas. Using a graphing calculator. One important use of equivalent formulas arises when using graphing calculators. Often formulas that are entered must give y in terms of x. Okay? So, like I said before, example 3 says, use a graphing calculator to graph this equation. First thing we have to do is solve for y. Okay? So, when I solve for y, inverse operations, the first thing I got to do is subtract 5x. Because I got to get y by itself, so I subtract 5x. Whatever I do to one side, I do to the other. Leaves me with the negative 2y is equal to a negative 5x plus 100. Can't combine those. Different things. Got to get y by itself, so I got to divide by 2. A negative 2. When I divide by a negative 2, I get out y equals a negative divided by a negative is positive. I just leave this as 5/2 x. It's fine leaving it like that. Some of you are going to write it as 2.5. I'm fine with that. A positive divided by a negative becomes a negative. 100 divided by 2 is 50. Okay? I apologize for not having this up. My calculator, so it's going to take a few minutes here. But then once this all comes up, you're going to be able to hit your y equals 5/2 x minus 50. Didn't take as long as what I thought. Clear this stuff out. 5/2 x minus 50. Now I'm going to give you a little hint. This is my y-intercept. So when I graph this, my guess is my window's in standard viewing window, so it's not going to see the y-intercept. I might not even see this line. So if I hit graph, oh, it is big enough. But some of your calculators are going to look like this, okay? And you're probably thinking to yourself, Mr. Johnson, I can't see it. Yeah, here's the reason why you can't see it, okay? Your window. Your y minimum only goes down to a negative 10. The y-intercept, if you look at this, is at a negative 50. So just to see it to go through the y-axis, you have to be all the way down at a negative 50. This is very important. Some of you that don't understand this of what graphs look like. Okay? My y-axis on this graph, my y-intercept is clear down at a negative 50. Okay? That's this point right here. And then it has a slope, and then it goes through here. So if your window only goes to a negative 10, you are not going to see this point. So what do you have to do? You have to change your window. Okay? So I got to change my window at least to be a negative, I don't know, 50, 60. Well, it's got to be more than a negative 50, so I'm just going to say a negative 70. Okay? That way we get really below it. Okay? And so, yeah, as you can see, here's 50, and then there's my 70. So, yeah, now I can see my line as it's graphed on the calculator. Okay? Very important to know. You're going to have that for a quiz. Thank you very much. I apologize for a little bit longer with the calculator. We'll see you tomorrow.